Welcome you to the next session of embedded software testing. In the previous session, we had seen some of the different levels of testing in terms of how different modules are organized. Taking an example of about 12 modules, uh, how unit testing level it is getting organized, integration testing, system testing. So we have detailed about each modules or components, how it is disintegrated or integrated at a higher level. Then we discussed about setup, host and target, how it looks like, what will be the host based development and testing, what will be the target based development and testing. So what is the likely environment, so what is the test system that is going to be used, and test system with a realistic input provided from the system perspective. Then we have seen through some of the target based debugging techniques with the help of simulation, emulation, target monitoring, simulators, simulator disadvantages, then emulation, what are the emulation techniques that are used. Then we have the target monitoring, where the monitoring program will look into the target events and the data is going to interact with the target. So the tools and their usage also was discussed, how it should be used. I think today we will go through some of the commercial tools as an example. We'll come to know. So these tools, basic tools which we had listed out in the earlier class. Of course, we went through some of the embedded systems or embedded system words. We need to be aware of these words. So the next session we will take up. So in this session, I will provide you few questions or exercises which you can make a note. But with few questions on what we had studied in the previous class, lecture 6. The first one is about why simulators can't be used for the complete testing. What is the major difference between simulator and emulator? So just you need to tell why it cannot be used for the complete testing. What is the major difference between simulator and emulator? Why do we need I hope you understand the question. We all know about ESD setup, embedded system testing setup, and configuration also we know. Why should we configure? Then the last one being provide a brief sentence for the below: test harness, test bench, fault injection, IO, ICD, breakpoint, simulator, emulator, ICE, profile. So these are some of the exercise questions for the previous lecture. Okay, we'll move on to the next one. The first slide of this lecture. We'll discuss about PM method. We have seen several approaches, generic way of how to write test cases, test design, and test approaches in a generic way. Given this form, we have seen different examples and all that. There is one unique way of definition that they have used. This is basically defined by Bart Brookman and Edwin Norton. There is a book called Testing Embedded Software by Bart Brookman and Edwin Norton. You can download or you can Google it. It's a good book about a TM method. Basically, one chapter he has discussed in detail about that TM method. This is another method of embedded testing. So I had highlighted some of the points from that book. We will walk through that, and in detail you can go through that book, and we can see the differences of the general and the TM method. Okay. Uh, Testing approach differs per embedded system. We know that different embedded systems will have different approaches. It could be a computer electronics, or it could be a home experiment, or it could be an automotive, or say telecom, or aerospace, or space, whatever. There are different varieties of embedded systems that are being used. Of course, there are different test approaches and methods that is also followed. There is no unique test approach that is available. I would say if you take up two embedded systems testing over a period, the approach will be definitely different. The approach in the sense, the basic criteria or the uniqueness between two embedded systems are not considered. So I would say there is no unique test approach that is being addressed for doing this. Example, testing a mobile differs to testing a brake control system. Uh, Mobile is a small device having one or two major processors or couple of interface devices, and brake control unit system is one of the major components that is having complex algorithms, etc. Complex interfaces will be used in a car, let's say. So definitely the testing approaches will be different in these two. So we cannot apply something, say some method I have defined for testing a mobile, and the same method I will use it for brake control unit. I don't have a unique approach. But when you uh, go through the approach that we have used, when you narrow down some of the finer elements of this approach, definitely there are similarities. Uh, Similarities in the sense that when we are testing it, we will result in either issues, or we will revert back in terms of test case or designs, in terms of fixing the failures or retesting it, whatever it is. Uh, there are nothing but issues and the solutions for those issues in the embedded testing methods. So these similarities are cleanly organized as a structural testing. That is nothing but TM method. TM method is nothing but organized way of embedded system testing, having identified the similarities of different embedded systems. So these are some of the definitions that are used. Definition: TM is a method that helps to assemble a suitable test approach for a particular embedded system. That means we will define some of the structured approach. From there, we will draw or assemble some test approach which will be suitable for a particular embedded system. It provides a mechanism for assembling suitably dedicated test approach from the generic elements applicable to any test project, and a set of specific measures relevant to the observed system characteristics of the embedded system. So what it means is it provides a mechanism for assessing suitability. That means we have a generalized or structured approach. So we'll pick up a suitable dedicated test approach from the generic elements, which could be applicable, as I said, for mobile device or car device, whatever it is. So it could be any project within the embedded system for a series of devices. And followed by that, we use specific measures relevant to the observed system. So what we do is basically we identify some of the similarities, or it is called like characteristics. For these observed characteristics, there are specific measures that will be used in the embedded system. So these two are very important. One is the characteristics of the system, then specific measures that are required for the particular system. So this is very important while taking the TM method. So this is what the definition of TM method. This is clearly defined by the TM method approach document inside the book by Bart Brookman and Edwin Notenbaum. Okay. Okay. So let's go into the TM method overview. So what is the structured embedded testing method? So structured testing comprising of the four elements, that is life cycle, infrastructure, techniques, organizations. This is structure. That means life cycle, infrastructure, techniques, and organization is also called as short form LITO. So these four elements are structured inside the TM method. You can see a diagram which explains the overview of the LITO. That means the dedicated test approach is also based on basic elements and specific measures, as I said in the previous slide. So all these are related to the cornerstones of the structured testing. That means the structured testing of the TM method is basically based on these things. So what we do is we will define the TM generic. We will use the specific measures of the particular system. Then we will apply using a mechanism called LITO. That is life cycle, infrastructure, techniques, and organization. That will result in a method called dedicated test approach. So this is what is the overview of TM method. We will take up each of these LITO, life cycle, infrastructure, techniques, and organization. What is life cycle? This defines the which activities have to be performed and in what order. It gives testers and managers the desired control over the process. We will have a separate on the life cycle in the next or the forthcoming classes that will detail about life cycle, different testing life cycle models definitely. But in a shorter form, the life cycle defines which activities have to be performed and what is the process, what order it has to go. There is a thing called entry and exit method. So that will define all the objectives, inputs, outputs, and the process items. So basically, the life cycle gives a desired control for managers as well as the testing team on the overall process of the embedded testing. Next is techniques. This helps with how to do things by defining standardized way to perform certain activities. That means techniques will identify how to do the testing by defining some of the standardized mechanism for testing activities. Once we have these two, then we will have the infrastructure. That is for the above techniques, what is the needed environment? So what is the infrastructure that is needed? So this defines what is needed in the test environment to make it possible to perform the planned activities. It means we have defined the plan here, we have defined the technique and what it needs to use these techniques. That is what infrastructure element defines in the TM method. Once these three items are there, then we are going to have another one called organization. This basically defines the roles and required expertise of those who must perform the planned activities and the way they interact with the other disciplines. That means the organization defines the various roles and responsibilities of required people for conducting the test. So that will basically identify different people or expertise or who is required. So in the above three things, we have defined the plan, we have defined the techniques, and we know what infrastructure is required. Once these three are laid out, we need who has to do all this. Who should do what actually? Who should lead the test team? Who should do which functionality test? Who should do what? So all these things will be covered under organization. So this is very important. Basic things about PM method, life cycle, techniques, infrastructure, organization. It's called LITO. Once again, I will go through the previous slide. Why? Because to make it clear that LITO is an outcome of the TM method, which will be applied for the test, the embedded test under subject. So for LITO, basically we will have specific measures for the particular identified embedded system, and there are generic approaches or methods that also will be used. Combining together, we will come up with a mechanism for these two basic elements, and that mechanism will work out LITO, that is nothing but life cycle, techniques, infrastructure, and organization. So these four are how organized is what is being depicted in this figure. Figure 2.2 is nothing but actually this is a reference to the book which I was telling just now, testing embedded software by Bart Brockman. I think I have put the reference for you, so probably you can make a note of this. So these four cornerstones are the important items of the TM method. Life cycle, techniques, infrastructure, organization. Life cycle is welcome in the whole organization. Infrastructure is supporting it. Techniques is the next thing. Then we have the organization surrounding this life cycle. This will be organized. So let's go in further step, having a little details about life cycle. In the life cycle model, the principal test activities are divided into 5 phases. What are those 5 phases? We will tell in the next slide. Figure. So basically, the life cycle model is divided into 5 phases. In addition to the phases of planning and control, preparation, specification, and execution, a completion phase has been defined to round off the test process satisfactorily and to formally deliver the test web for the organization for subsequent maintenance release. So what it tells is it will basically provide the different phases, and in addition to that, it will also help in planning and control, preparation, specification, and execution. This is a complete phase having different elements. So basically, the outcome of this life cycle is to identify or measure the outputs that are come as a satisfactory result of the testing. So what are the 5 phases that are defined under life cycle? The preparation, specification, execution, completion. These 4 all under one box called the PNC. That is nothing but planning and control. So there is a preparation phase where the tests are prepared or the test planning is done. Then once the test planning is done, we are going to define specification. It is nothing but test specification, not the requirement specification. That will identify all the test case, test scenarios, and all that. Then once we have defined all the test cases, procedures, and the execution mechanism, we will do the execution with the help of the next phase, the third phase. Then the last one is the completion. That means this is nothing but reporting the result, capturing, logging, and all that. The mechanism will be part of the completion. This also can have disability in terms of coverage, etc. So altogether, this will be done with the help of the organization under the one phase, which will be throughout this 4 phases. It is called planning and control. So 5 phases of the life cycle are basically divided into preparation, specification, execution, completion, all being comprised under the planning and control. And so anything did I miss? Okay, fine. Okay, let's go into the next one. That is nothing but techniques. So what do we do in the techniques? As we said, all the testing methods, testing mechanisms, all have to be defined under techniques. So this cornerstone of supports the test process by offering testers elaborate, proven, and universal working methods, as well as enabling the management, that is auditors, or supporting team, to track the progress of test process and evaluate the results. That means this techniques element will have test process in terms of testers elaborating a proven method or universal working method for testing the complete embedded system. So this will also help how it can be helping the management or the quality team to track the progress of the testing process and evaluating the outcome of the test. In principle, one or more techniques can be devised for every type of activity. See, the testing is basically divided into different activities: manual, automated, and white box, black box, etc. So all this can have a different devised techniques. These techniques are developed somewhere the world almost every day. Uh, Whenever an activity exists which is likely to be repeated several times, the future test process would be supported by devising specific techniques for that activity only. It means we have several techniques and all that. So we are going to have all under this techniques method, so which will be used for uh, tracking and monitoring the testing process. So this is all part of the techniques. So this can have any activity that is part of the test process in terms of defining testing, etc. Test cases, procedures, all that will be part of the techniques. And of course, we can define techniques to have safety analysis. In addition, I'm telling about basically this will help the complete picture of the testing, test design, test automation. This could be from a test data. It could have process and checklist, etc. So all this can be part of the techniques. So that is about the second one. So we have first cornerstone as life cycle, second one as techniques, third one is infrastructure. So far we have defined the life cycle, we have defined the techniques, and now it is the infrastructure that is required for implementing the techniques. Sorry. The infrastructure for testing includes all the facilities required for structure. Structured testing is nothing but the organized method of doing it. That is nothing but TM method. It can be divided into facilities needed for executing the test. It means the test environment or test net or test that facilitates that the facilities that support efficient test execution, tools, support tools, any automation, any batch execution. All this will be part of the test environment or infrastructure. It can also include the facilities for housing the staff. That means the testing staff would need some infrastructure in terms of taking their needs or their disk or any internet or any support tools or anything that is needed for the embedded testing to be carried out efficiently. That is what is the infrastructure items that are required, and that can have hardware, software. It can have a test database, any equipment that is needed. There are broad categories. That book talks about that. Maybe we can touch base this method separately in a different class, detailing out each of the elements under the infrastructure. Of this environment for the support staff can also be part of this infrastructure. Okay, coming to next is the organization. So now we have defined life cycle, techniques, infrastructure. Having said that, all these are in place, documented or available. Now, who should do this? How it is organized with different roles and responsibilities for various people. These are all about, this is what is told here, all about people and how they communicate. It is not just enough to have people assigned. There should be a mechanism how people interact and in terms of helping each other or reporting or strategizing, etc. It's like a teamwork, and mostly the embedded testing will be done by an independent team in any of the organization to take up automotive or aerospace space, because the independence is very much needed in the industry to basically get unbiased as a developer. Okay, so testing is not a straightforward task that can be performed in isolation, unhindered by interferences from a demanding outside world. The involvement of many different disciplines, conflicting interests, unpredictability, shortage of expertise, and time constraints make the setup and management of the test organization difficult task. So basically, this tells about what are the various nitty-gritty details that are involved for having an organization, having various sets of people. What are the challenges that people will have, whether the people or the team that is going to do the embedded testing is having a sufficient expertise, or any interest, lack of interest is there, or a certain guy is having expertise or interest in a certain area. He should be allocated accordingly. And so what is the efficiency, what is the time constraint that he can have. He may have some leave plans and all that. So all this will be considered for making this organization complete. So that is about a little the life cycle, infrastructure, techniques, and organization. So some of the points is mechanism for assembling the dedicated test network that we know. Basically, so far it explained the principle of user systems characteristics to state what it is that makes the system special. It means we will define some of the characteristics. We know that we will first identify the characteristics. Then, for testing those characteristics, we need to have test approach. That is nothing but dedicated test approach. It is important to note that the TM method does not aim at achieving a scientifically accurate and complete taxonomy of embedded systems. Rather, its purpose is entirely practical and purely from tester's perspective. As I said, the test approach and the methods that are being used have to be purely from realistic or practical nature. So we just cannot design some test case and say that all these have to be tested and the results will come. So we need to visualize from the practical sense. That's very important. I will just underline a few things that are very important for doing the embedded testing. Characteristics. So basically, we need to have a thorough understanding of the system. That means a bigger picture has to be there for the system which is under test. Once we identify that characteristics of that system, then it's easier for making us writing the test approach. And other thing is, it should be very much practical. Whatever we write, test case or test procedure or execution steps have to be realistic and practical. We cannot have something which cannot be tested or which cannot be fed some certain values. Suppose sensor is supposed to take something like 20 degree to 180 degree of input, and it is limited with that input. We cannot afford to provide some minus 100 degree or 300 degree centigrade. So we should see all this practicality of that particular sensor in order to make it realistic test approach, and it should be purely defined and have the ownership of the tester. So it's from the tester's perspective because he is going to test it. So that is why it is very important to have these things in place for TM method. So it will also help in assisting the test manager in answering the question like what makes the system special and what must be included in the test approach to tackle this. So the system he has an understanding. He will know what is making this system and what should be included to make this system testable. That is test approach. So these are some of the few or key items that needs to be understood or used before devising the TM method using the Little principle. Okay, so we said that there are a few characteristics or the complete characteristics of the embedded system under test had to be used. Once we have that characteristics, we are going to have measures. Measures is nothing but the test approach of how we are going to do for that characteristics. Some of the characteristics that are usually used in any of the embedded systems are as below. All these have to be considered for doing the embedded system testing. Safety critical systems, technical scientific algorithms, autonomous systems, Unix system, one-shot development, analog input and output or mixer signal, hardware restrictions, state-based behavior, hard real-time behavior, control systems, extreme environmental conditions. So these are some of the definitions you have come across in embedded systems course, or it is the taxonomy of the embedded systems. Like we know safety critical systems like aerospace or automotive, so which have to be safe because it's very important that the systems cannot go for faulty, which will result in safety hazard. Then there are certain systems having technical or scientific complex algorithms. Those related tests also we have to devise testing methods. So the other characteristics is autonomous systems. which will be having its own intellectual property or define the methods of implementation. One-shot development or rapid development kind of a system which will be used in a short cycle. Then we have systems with unlocks, purely with unlock inputs, unlock outputs. Of course, the split is not listed here because most of the or almost all the embedded systems will have these codes. So it doesn't mean that unlocks will be there always. This is one of the characteristics that we used. And any hardware limitations or restrictions that are to be considered. And state-based behavior, like different states the system can enter or exit. And any hard real-time behavior, like when the what is hard real-time system? The systems something like medical devices such as X-ray machines, which are scanning a human, have to have a hard real-time behavior because it cannot afford to miss the deadline. Otherwise, it will result in any of the damages to the human. And of course, we have control systems such as closed loop control systems or open loop, whatever it is, motor driving systems, etc. And there are systems like military applications, they use environmental conditions. They also have to be considered. So these are some of the characteristics that are used in PM method. So these are very important things that needs to be considered for developing the approach. Example for one-shot development, I would say the systems which you cannot come back or which cannot be repaired, also called as one-shot development, such as satellites which are launched only once and cannot be maintained. We cannot maintain it; it's very difficult. But nowadays there are shuttles and all that which will help or support in terms of upgrading the software and all. But in generally, these kind of systems, once it is released, cannot be used for maintenance. That is about TM method. So we know that TM method has 4 cornerstones, and with the help of these 4 cornerstones, life cycle, techniques, infrastructure, and organization, we will devise the TM method. And before we develop the techniques, we use specific measures for a certain amount of characteristics, such as the below ones. Of course, there are other things which are discussed in the book. Maybe I'll touch base in between when it is possible. They say there's a little matrix, they use it. Yeah, I think we can touch base little matrix in the one of the sessions. So there is a question for TM method. We can make a note. How TM method is different than normal embedded system testing. So we have gone through normal embedded system testing in earlier sessions in terms of test case, procedures, and all that. How this is unique or different than the general embedded system testing. So that is about TM method. We have gone through the various embedded system approach, environment, methods, all that in general. So I would like to categorize for embedded system testing some of the tools how they are being used or how they are organized basically for embedded systems. So these are some of the master tools that has to be there. Of course, the same tools can also be used for development also. So the categories are something like this: test equipment. Test equipments will have oscilloscope, logic analyzers, or DMM, digital multimeter, etc. We have a diff merge tools. This is explicitly used for test cases or test procedures. There are various versions that test development team need to uh, do it while doing the changes and all that. Like win merge or beyond compare. These are some of the tools. I'm just writing the examples: digital multimeter, etc. Diff merge tool, something like win merge, beyond compare. Then we have a static analysis and metric tools such as understand for C++, C. Then we have Bugzilla, test links, defect management tool, something like Bugzilla, etc. JIT, so many are there. Next we have text editor tools, something like Notepad, TextPad. You can use it for evaluating the test results and all that. So not only it is used for development, it also can be used. Code checker, something like QWERTY, they use checking the code. Here code checking is not that C or ADA or whatever the language checking. It is something like alignment and as per the coding guidelines, it is there or not. So this will cover basically. Of course, we have rules, coding rules, something called C. I think 2004 and of late 2011 also will come. I'm not sure about that, but these are some of the stringent guidelines that they will follow. For validating that, we use some of the code checker tools from Telelogic and all of them. So we know that IDE like IAR, workbenches, Eclipse. Then we have Lauterback, multi. What is that? Multi, Lauterback, IAR, workbench, etc. Of course, we have Code Compose Studio from TI also used. Hex editor, some of the binary or images, raw files, and all that you want to view it, you need a hex editor or hex viewer tools are there. So there are tools. And for reverse engineering, you can use static tools such as understand, which will have the call tree mechanism. Which will be used for reviewing and all that. So it will be very useful to have reverse engineering tools for some of the testing. The more the system, the more complex it is, better to have a control on the system through some of these call tree identifications or how the code is structured or how the modules in the system is structured. So this will help basically. Disassembly tools usually are inbuilt around the ID. which will disassemble the object code basically. Then we have a dynamic analysis tool like runtime profiler, and profilers part of the stack trace, etc. Time machine from Lauterbach, sorry, multi. So like this, there are various tools. So but basically these are some of the categories that are commercially used for embedded software testing. Other than this, there could be some manual tools also, which will be developed in-house. That is need basis. There are other tools like static analysis, Cantata, LDR test bed, Coverty. Then for complexity measurement, we use is one of the important thing that needs to be done in embedded system. We cannot have a certain amount of complexity going up for the embedded systems. It has to be limited within that. It's called McCabe complexity. They use understand C, C, C++ is one of the good tool. They use it to analyze the complexity of the code. Then dynamic analysis tool, we said that runtime profilers and machines are all used. So these are some of the commercial tools category. Okay. I had put an Excel sheet covering some of the embedded system tools that is used in the industry as an example. So don't take it as it is used certainly in a certain project or product. I just generalized, so as an example, so we can just have a look at how it is. I hope you are able to see and it is shared. Okay. So this list basically lists out tools and automations, and what are the tools that is being used in different phases. I have covered for all the phases of the embedded system. Development phase, configuration phase, verification phase, reviews, usability, and project tracking or management. So these are some of the phases, and each phase will have a different activities. Like development phase, we have requirement management, code development, requirement support. In the configuration, we have configuring all the configurable items and deliverable artifacts. And verification, of course, our topic is that test cases we develop, and if it is a model, then model-based coverage we use, model-based testing we do, testing in coverage we take care. Debugging is also used as one of the testing techniques. Reviews will be using it, analysis, static analysis, etc. And we have for reviews code review and any checklists that we use for reviews. That also is one of the activity. Then we have the traceability for test cases, test scenarios, test procedures, test results, both upstream and downstream. I will tell you what is upstream and downstream in one of the class. And traceability is very important part. It is not just tracing the test cases. TC2 requirement also needs to be done so that we have a coverage of the testing for all the required requirements. The SVP is nothing but the plan or this plan, I would say, software plan. And for project management and tracking, we use test and defect management artifacts. Okay, now coming to tools. What are the tools used for development phase? For requirement management, we use doors. It's from IBM. Then we have a rectify. Then for code development we use the MPC series target or evaluation board. MPC is nothing but the PowerPC series from Freescale. We use for development or debugging the ID integrated development environment such as GHS. This is just an example. It could be different for different embedded systems. And for requirement support, we use capturing all the requirements, making it tabulated and all that. We use Microsoft Office, Word, Excel, or Visio. And for design and all that, of course, we use Visio or any of the design tools. So its version also is listed next to this. For configuration, this is very important aspect of the embedded systems. The items which are under test, which are under development, have to be configured. They should be controlled. So that will be done with the help of 7 dimensions or SVN subversion. Test cases, we know we use Microsoft Word with the templates we have discussed, an Excel sheet for having the test cases identified. For model-based coverage, we use the MDC. Some of the model-based testing after we develop the model test cases, we use SCAD QTE, qualified test environment. For testing and coverage, RTI is used. It is from Rational. This is one of the good tools they use it. Of course, there are other tools like LDRA, Vectorcast, etc. For debugging, as I said, for verification testing, we use debugging methods also. The same ID is being used. What is being used for development cycle? Of course, we have reviews using various review cycle process with the help of Excel sheet or Word. Analysis can also be done with the help of Microsoft Office. Stack analysis. This is one of the important thing that many embedded systems have to be tested. Stack, that is nothing but the memory aspect of the system that is running, how much stack it is using, what is the maximum it can reach, and whether it is clearing it or deleting the stack, etc., freeing the stack, etc. Of course, for reviews, as a separate phase, we have C reviews, C and C++ code review, QAC, source monitor, coverty, core collaborative, tele logic, logic scope, Mr. rule checker. For ADA language, we use PC. Tele logic also is there for ADA language reviews. Traceability is one of the important aspects of this. You can either automate using scripts for the test cases, whatever you have developed, to cover it. And as I have put up that script, you can have the Word or Excel sheet report. So that's what I have mentioned. You can automate with the help of Python or Perl to extract the data and populate the traceability sheet. So basically, all the test cases and procedures, they will have a unique ID. Those unique IDs are used to develop the traceability. And how they are done is with the help of automation tool such as Python or Perl scripts that are being used to develop it. For test defects and management, we use TestLink and Bugzilla. Maybe we'll have a separate session on how it looks like and how it is getting used. And also there are possibilities that SVN and JIT also can be used for test defects and test management. Okay, so these are some of the tools that are used for a typical embedded system. So this is very specific, so you don't have to get biased with this. I have just listed out as an example. So that is about the commercial tools categories in general and an example of commercial embedded system development and testing tools. Okay, so again, every session I think we will have these words which we have gone through or which we can use it. So this will be growing all the time. Test harness, test bed, test bench, automatic test equipment, model based testing, test steps, test driver, fault injection, MCDC, test hook, boot software or bootloader, input output, ICD, interface control document, breakpoint, simulator, emulator, tracing, profiling, and data sheet, errata, IC circuit emulator. I think last time we stopped with this. Now today I have equipment, or you can say test equipment, which will have the necessary test environment items like test harness elements, part of the test equipment. It also can have items such as oscilloscopes, logic analyzer, and any of the measuring equipments. Then, as I said, the code checker for code reviews and all that, static analysis, dynamic analysis, X, raw file editing, reviewing, disassembly from the object file, then reverse engineering. So these are some of the embedded system modes. I think the questions I have got for this class. TM method question. How TM method is different than normal embedded system and normal embedded system testing. Okay, we'll see you in the next class.